Thank you. Thank you for waking up and dragging yourself in on the last day to a morning session. Maybe your second session if you went to the lightning talks. But whether this is your first or your second, thank you. And thank you for coming to my somewhat opinionated, at least in title. And let's be clear, obviously if you're teaching Intro to C, that's a fine thing. My complaint is for people who are not teaching Intro to C, but who nonetheless start their 5-day course with 2 days of C material. So this is my suggestion for how to have a course that is more enjoyable and makes better C++ programmers, which is probably the whole point of teaching anybody anything. So who am I talking to when I talk about teaching at all? Yes, officially trainers, people who stand at the front of the room and pontificate for a while, something I've been doing for decades. But also people who, for example, just mentor other people. If someone comes to you at work and says, how do you blah? And you go write them a little 10-line thing that demonstrates how to blah. I want to talk to you about how you write that little 10-line thing and what you use in there. And if you have an API and you are the one who writes the samples, Windows team, maybe you could actually, write samples that look like they were written in this century. So it's not just sitting down and teaching somebody C++ 101. It's all of the times that you demonstrate something to somebody who is new to whatever you're demonstrating to them. What do you wrap around it, and what do you consider the accessory that goes with that something that you're teaching people? And one of the reasons for this is this concept that I talked about in last year's talk, where we said one of the great things about C++ is that it's a language for smart people. And one of the bad things about C++ is that it's the language for smart people. And why is there this sort of like barrier to entry that says you have to be super, super smart? Believe it or not, a lot of it comes from what we put people through in the first 2 days of their 5-day Intro to C++ course, and that isn't even C++. And that's kind of where I'm coming from, that if you change things around just a little bit, you can actually make the entire learning process go more easily and produce better developers out of it. Now, who here learned C first? Right. So there's a very strong temptation to reduce it to the previous problem, right? You know how to teach C++ to someone who knows C, so step 1, teach them C. Step 2, do the thing you know how to do. I'm not saying that doesn't work, because it worked for a bunch of us, but personally, I learned C when C++ didn't exist. Can I have another hand if you're in that category? Yeah. So, that's a long time ago, right? And an awful lot has changed, including the percentage of people who are just wandering around on the street knowing C. So to try to say, well, I know how to do this delta, so that's the only way I can teach it, you're actually just making it all take longer. And you're teaching people bad C++, right? A C program is a collection of functions. And some of them have names that enable you to know that they belong together, like all the str functions, but that's really not what you call object-oriented design, right? When you teach people C, you don't teach them RAI. You don't teach them the same kind of type safety, because those things aren't in C. You can teach people these things on day 1 if you don't spend day 1 on some other stuff that I don't think you should do. When you do it C first, you make it look harder than it is, and you teach them things that they have to actively work hard to learn that on day 4 you will have to try to unteach them. And so I'm saying, like kind of revolutionarily, just don't teach them that part. And then long before day 4, they are ready for you. Before I build out this slide, I want you to think for a minute, what's your answers, and I know it'll be more than one, to this question. You know other languages, not just C, like Ruby, Haskell, Python, JavaScript, F#, C#, blah, blah, blah. What makes C++ specifically and uniquely C++? You have 1 candidate, you have 10 candidates, hold them in your head. Is that a question?
No.
Okay. Now, think about what day of the course that thing gets discussed, or what chapter of the book that thing gets discussed. Because this is what we see, right? When I did Intro to C++ the first time, and I picked up the textbook the previous university professor had used, and it was chapter 32, Objects and Classes, because they had just took their C book and stuck some more chapters on the end, right? And it keeps going, Eventually, sometime 3 or 4 chapters after classes, we might talk about operator overloading. Templates, it's pretty advanced, we'll leave that. Const is often even further down the line. There are some seats up front. Which some of this has to do with what order things were added to the language, right? So you've got a perfectly good 32 chapter book, and then someone goes and adds const to the language, so ta-da, chapter 33. Similarly, exceptions, the standard library, because we're all terrified of it. So we leave that till the very end, and then of course once C++ 11 comes along, have to add some more chapters at the end. But isn't this stuff that you said made C++, C++, right? So why are we saving it for the advanced course, right? Or for day 6 of the 5-day course? If you're going to teach somebody C++, I would like to teach them these things and not the delights of the printf format specifiers.
Now I actually do have a question. Where's deterministic destruction?
Sure, we can put RAI in here. That's excellent. Let's put RAI in here too.
That's the first thing that I
That's
teach,
right.
Because that's what really makes it
That would be
C++.
first. Exactly. But if I were to put this in here, yeah, I'd probably say it'd be about chapter 70, right?
Yeah.
C came first. My answer to that is so, right? Fortran came first also, but we very rarely say, now let me just explain Fortran to you for 3 days, and then we can get into objects. I'm not saying that it's not possible to teach C++ to someone who happens to know C or any other brace bracket language, right? You say, good, we can skip all the bit about if and for and while and what a Boolean is, because you know all that, and we can skip the day where we do ands and ors. That's fine, but doing that to people who don't know any C++ is, I believe, actively harmful. So this isn't just about you can skip this stuff. You will be a better either teacher, trainer, sample writer, parent if you do skip the C. And yes, parent, I did teach my children C++. Teaching people C first makes C++ developers who are not as good as they would have been if you skipped that part. It makes people who didn't like the course. You know, I move in a wide variety of circles, some non-C++ circles. I actually talk to marketing people and business people. And if I had $1 for every time I heard this sentence, oh, C++, I took that in college, man, I did not like that. And they're looking back 20 years and they're telling me the only memory they have is how they didn't like it. That is so sad, right? Because here's a room, a building full of people who love C++ and enjoy it. When I stopped teaching them the sort of day 1 material and day 2 material that I used to teach them, people started enjoying my courses. Okay? So show them what makes C++, C++, make the course more fun, get through the boilerplate intro stuff faster so you can get to the super cool stuff, and don't set up this really false complexity. The 4 things I really want to rant about, I have more than this, but these are the starting point. Strings. Heaven help me, strings. Printf, square bracket arrays, pointer manipulation, and new and delete by hand. Now, a couple people have grabbed me over the week and started to try to stick up for printf or to tell me how they feel about stream performance. I am not here to defend stream performance. I'm not even saying that you shouldn't use these things in your own code. I'm not even saying that you shouldn't ever teach them in your Intro to C++ course. What I am saying is that using these on day 1 of your Intro to C++ course so that people cannot even do Hello World until you explain and draw on the board with the little boxes and the arrows and the null at the end of the string is not right or fair. Okay? Not on day 1, not on day 2. In order to do char star strings, you have to explain pointers. You know, when I taught my 12-year-old C++, his first program asked him his name, and when he typed it, it said to him, hello, Kevin. 12-year-olds love that. 8-year-olds love that. How do you teach that in C++ if you're a printf scanf person? What do they have to do to get to there, right? There's no earthly reason why they need that. You are into off by one land, and oh, you forgot to allow for the null terminator, and no, we always say less than for the termination condition in the loop. 5 minutes in. And you know what they are thinking? This C++ stuff is hard. And I don't care for that. So, instead, you should use them strings. Everybody can read this code, right? 8-year-olds can read this code. They know that plus means putting two things together. If you've done one where you use equals equals to compare integers, they instantly understand that equals equals is for comparing the strings, and it doesn't take long to explain plus equals. You don't have to tell them about operator overloading. You don't have to tell them about C++'s strongly typed behavior. You can just show them some code and they get it. They probably think string is a built-in type, especially if they know another programming language where string is a built-in type. You don't need to disabuse them of that. You can focus on whatever you want to focus on, whether it's ifs or loops or something. The fact that there's a string class for them is a minor miracle to those of us who started learning in the 80s. It's not a minor miracle to the people you are teaching today. It's just how the world is. And you don't actually need the long diversion about what it took to get us here and all of that. You can just show them how to manipulate some strings. I know some people love printf, but I want you to remember the first time you ever printf'd anything. Somebody got out the big table, right, with the %C, the %S, the %D, the %F, the da-da-da-da, when you put dots, when you don't. Somebody wrote a program where they said %C, but they should have said %S, or the other way around. That stuff is kind of gross. And it's not actually key to being a good C++ developer, right? Like, I don't think I've ever been in a job interview where someone's like, no real sense of architecture, doesn't understand objects, a little bit loose and fast on the whole casting story, but totally has all the printf specifiers memorized. So that's higher from me. And we're teaching this to people at 10:30 in the morning on day one. And if they get it wrong, their programs don't work. I just think that's not fair or nice or right or useful. Still, again, doesn't mean you can't ever use it in your own applications should you need it. So then people are like, well, what should we do? How about nothing? I programmed with cards. I did. I went to a room, I handed cards to a nice person, and about a half an hour later, I got a printout. My mother put cards on a truck, and she got her printout the next day. And if you live then for your application to have print statements in it is super smart and useful, because how else are you going to know what the value of I is after you incremented I, or whether or not we went into the loop? But we don't do that anymore. And they have to learn to use the debugger anyway, right? So how about in your very first program where you're showing them the operators and you're showing them what if is and you're showing them how a loop works, you just have them go through it in the debugger and look at the values of things instead of putting the values of things on the screen at all. And now we don't have to argue about streams, right? Don't use anything. If that doesn't work for you, if it's really super important for you to be able to have them run the program and see the output then, okay, use streams. That's fine. You can put in a little disclaimer here about performance and point out to them that if they have a large amount of information to process, that there are other things we can do, that there's more than one way to do everything in C++, and then you can just move right on because it is day one. Or if you are an in-house trainer, you're training your own C++ developers who are going to work for you building something in a framework, then why not teach them that framework? So if it's some GUI thing, why not have all your sample apps have like a button that makes it run and a text area that shows the output, and they put text into the text area with whatever way it is you do that in your framework, probably by setting some string to a value, right? That's another option. There's nothing important in printf that they need to know in order to understand how an if works or how a for works or what the plus plus operator is or what the greater than operator is. So let's skip that bit. Square bracket arrays, like char star strings and like printf, they lead people into mistakes. This is like putting chocolate out on the table and then leaving a bunch of 5-year-olds there and going out. And when you come back, surprise, some of the 5-year-olds ate the chocolate, right? You're putting this opportunity to not allocate enough, allocate too much, start at 1 instead of 0, go too far, blah, blah, no bounds checking, undefined behaviors, on the table, and then leaving it with a bunch of beginners. And there's no actually really good reason for doing that, other than to impress upon them how hard this language is and how careful you have to think if you want to be one of our tribe. Plus, once you have these, even though you could use range 4 with a square bracket array, have you ever seen Intro to C++ material that uses range 4 with a square bracket array? I never have. They roll straight into the for loops, right? And what do they implement in those for loops? Most of algorithm, right? Let's now go through the collection and count how many entries have the value of 3, right? Because nobody wrote standard count yet. Sometimes this material predates range base 4. Sometimes this material predates algorithm. I get that. But that doesn't mean that it should or that that's right. Because you wouldn't want to hire the guy or girl who wrote their own count or sort or accumulate. So why do we start out by teaching them that? I'm not saying that nobody should understand the building blocks of their language. Go ahead and demonstrate a few things. But to sit there and teach them how to do all these things, because that's the way to do it, invites a belief in the difficulty level and in what day-to-day life is like when you finish your training course and start writing C++ code for a living that really is not accurate. So of course, vector. Some of you have heard my advice about vector. If you need a collection class, use vector. If you're special and performance matters to you and vector isn't going to work for you, no problem. I totally get it. Use vector. Even if the perf argument is a legit argument, again, we are talking about day 1 of Intro to C++. And there is no perf argument on day 1 of Intro to C++ other than you should know that there are a variety of collections available to you in the standard library and elsewhere, and sometimes you'll choose a different one when you are all big grown up and know how to choose what you need. Beginners, whether they are 8 or 28 or 58, think of collections as things. They already do. I remember being so thrilled when I moved from Fortran to PL1 because I could have a two-dimensional matrix of numbers in PL1 and I could write A equals B and I got a copy, which is totally not what I would get in Fortran. I would have to write a loop. When we teach them square bracket arrays first, they're in Fortran, they have to write a loop. When we teach them vector first, or other collections from the standard library, they're in PL1, which I learned PL1 in 1984, so we could consider moving to 1984 is what I'm saying. They already think that way. When you teach them square bracket arrays, come on, you've had this thing. Make an array of ints called A that's got 10 integers in it. They think A is the array, and you're like, no, that's the address of the first element in the array. And it takes you like half a day to beat that into the last stubborn head. I'm saying let's skip that bit. They want A to be the array. So do I. So does everybody. So give them an object like vector so that A is the array. They're already naturally thinking that way. The only reason it's hard to get people to think in objects on day 5, when you get around to chapter 37 objects, is because of all the time you spent making them think in terms of pointers up until that point. So just be object-y right from the beginning, and that means using vector and using string. And yeah, the first time you toss a vector on the screen, there will be angle brackets. And you know what? They don't even care. They really don't blink. You go, this is to say it's a vector of int, because you can have a vector of anything. And they're like, neat. That's all. Nobody cries. It's amazing. And of course, this sets you up for algorithm, right? This sets you up for a lot of good stuff. I will say, don't mention iterators, okay? Just because you're using vector does not mean you need to immediately start discussing iterators. Even when you're going to use algorithm and call begin and end, you don't need to tell them what begin and end returned. You just put the line up and you go, we're going to go from the beginning of the collection to the end of the collection. And they all like, okay, I like this language. This makes sense. Now, some people start, wait, you want to use vector, you want to use string, you want to use cout. What about all that std : stuff? You're not going to be wicked and put using namespace as a magic directive. Oh no, they won't understand. They'll think this language is all voodoo. Say we do your basic Hello World console application. Have you had that one person in the back of the room who's like, why does it have to be called main? I saw a sample somewhere on the internet where it wasn't called main, it was called wmain or whatever it was called. What's all that punctuation? Let's say we're doing the one with, square brackets and 2 stars and whatever else. What's going on in there? Why does it say include at the top? How do you say that symbol anyway? Is that sharp? Why does it say sharp include? Most instructors can't resist having a little speech once they get onto include files about how our philosophy is. We only include what we need, da 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 da. You can easily spend an hour on that if someone pokes you right. If you're going to have a return statement in main, why do we return from main? What does it mean? What does it mean to return 0 or 1 or -1? And of course, explaining braces and other pieces of punctuation. Whatever your first Hello World console application is, there's probably 11 lines of trust me and 1 line that you actually want to show them, and you're going to complain that I'm putting a 12th line of trust me in the form of using namespace std. Come on. Right? Day 1, there's a lot of trust me. That's okay. Put using namespace in there while you're at it. When you teach them header files, you can teach them not to say using namespace in a header file. If you're going to have lots of time at the end of the course, and I put it to you that you are, somewhere along the way, you can have them do a using of just using stood string, using stood vector. That's even better behaved than using the whole namespace. But on day 1, they can use the whole namespace, not going to hurt anyone. So these 4 things alone, these aren't even my revolutionary thing. These 4 things alone are going to make a big, big difference. You throw away char star, you teach string from day 1, you throw away printf, you use the debugger or cout or your framework or something. You teach vector from day 1 and throw away square bracket arrays, and you stay well away from pointers until after polymorphism, and I'll tell you how you can do that in a minute. And here's where you get to. Your beginners will be thinking objectly. That's how they think when they come in off the street. That's how they think when they're children. The only reason it's hard to teach people object stuff is because we taught them so much pointer stuff, and then we say, now throw all that away and think this way. They think a string is a thing. They think a vector is a thing. They don't have any idea how to write operator overloads or that they exist, but they totally understand that plus is different for integers and for strings, and you don't even really have to teach them that. They just get that. So you've got this foundation, and you can then start into the more difficult stuff. Now, let me tell you a story about me changing how I taught things. When lambdas came out, of course, people were all like, hey, we need a what's new in C++ 11. And I went out and I wrote this stuff. And so you're going to teach lambdas? Okay. Lambda has 3 parts. There's the square brackets, there's the round brackets, there's the brace brackets. Here are all the things you can have in the square brackets and what they mean. And here's a bunch of examples explaining it. Now, lambdas have a return type. Sometimes you can deduce it. Here's an example where the compiler can deduce it. Here's an example where the compiler can't deduce it, right? And I was very thorough. I had reasonable examples for all of them. And people didn't like that part of the day. Because there was no explanation of why you would want a lambda, or why it mattered whether you captured by value or by reference, or really anything. There was no compelling motivation for lambdas. We just sat around and talked about syntax for half a day. And syntax that was maybe a little bit hard to remember on first blush, or that invited people to make fun of that same syntax for being so punctuation heavy. So then I changed my mind. And I think I'm going to lay this at the feet of Sean Perrant because I wanted to teach people more about algorithm. And hands up if you feel guilty that you're not really using algorithm and Sean's making you feel bad. Right? I'll tell you why I wasn't using algorithm. Function pointers. I didn't care for them. I didn't care for the syntax of them. I didn't care for writing one-line functions. I didn't like having functions called square it or double it or is odd or whatever. They were hard to maintain and look after, and where do you keep them and all that junk. So we get lambdas, and suddenly the doors to algorithm open wide to me. So you teach somebody count. Maybe you write the loop first to count how many 3s are in this array, and then you show them how they can just call count to figure out how many 3s are in the array. And then you show them with a lambda how to tell how many odd numbers are in the array by using countif. You write a loop that breaks when you find something, then you show them how to use find, then you show them how to use findif. Is that a question?
Yeah, I'm curious because I feel like personally the syntax for C++ 11 lambdas can get a little heavy. Do you start with generic lambdas?
No, start with like, if you're starting with say find,
Yeah.
you don't get to choose your parameter, right? It's whatever the algorithm is going to hand you. Right. So I'll tell them, well, this is a collection of ints, so the algorithm will hand you an int at a time, so you take an int, right? So we're not writing a lambda like in space with no constraints. When you use it as a predicate into algorithm, you're actually fairly constrained. And so that kind of leads them in. And yes?
That violates dry. If you just say auto.
Sure, but you're teaching them what a lambda is, right? once they know what a lambda is, then we can go on the Cook's tour, right? Then we can say, I don't want to have to say int, doesn't it know, because if I get it wrong, it'll yell at me, which is my usual explanation for auto, right? I do something, I get the compiler to yell at me, and then I'm like, if you're so smart, you do it. So, and that's also what I'll do when I want to say, I don't want to have to repeat myself here in this lambda. You can use something like generate or iota where you've got some counter that's out of scope, so you have to capture it by reference. So you can kind of work your way through that syntax tour, but you come from a place of, here's a problem I have to solve, lambda's going to let me solve it. And while you're at it, you happen to be showing them algorithm, but you didn't say, now we will discuss the standard library. You just show them they don't actually have to write all of this themselves every time. Now this is, I think, the bit that's life-changing. And credit for this has to go to James. A number of years ago now, we were asked to do a one-day intro to C++ online. And everybody said, yo, what? And so this was part, we're like, okay, we're not teaching any of that C stuff. We don't have time. We're just going to jump into C++ with both feet. And when we got to polymorphism, I believe it was James, although I can't really remember because it was one of those moments where you got really excited. Let's not use pointers for polymorphism. Let's use references for polymorphism. And I know it sounds insane, but it totally works. And the punctuation story is a delight. Because when you start to use pointers, your dots have to become arrows. Everything has to be dereferenced. Suddenly, you get that compiler voodoo day, you know that day, where people are trying to do stuff and they get compiler errors and then they just start putting stars in front of things. And they put, like, they write star int a because that might work. You're like, no, you never put a star in front of a type. They're like, oh, whatever, I don't know, you can put it at the end. And they're putting ampersands at the end and the beginning, and they're just like randomly permuting until the compiler errors go away. Usually they create runtime errors when they do that. When they're working with references, it's still all just the same as when they were solid objects. So the only thing that's different is that there's a reference involved. And the cognitive overload of having to change their punctuation disappears. So here's how we teach this. You start with the stupid pointless demo where you have an integer and then you have a reference to that integer and then you change the value of the reference and ta-da, the original number has a different value. And everybody says, why don't you just change I directly? You're like, no, I'm showing you how this aliasing works, right? So then immediately get into a function. Have that function, take a parameter by value, change what it gets, and you leave, and the temporary is destructed, and da-da-da, and the original still has the same value, and you change it so it takes its parameter by reference, and then it really changes it. Once they get that, which does not take long, then, remember we already did objects and classes, set up a hierarchy with a virtual function, write a free function that takes something from that hierarchy, takes a base, and have it call the virtual function. When it takes the base by value, if you give it a derived, it will end up with a copy that's a base, right? And it'll call the base function. Then you do it with a base reference, and you pass it a derived, and it will call the derived version of the virtual function. We did this on the MVA day, we did this with a rectangle and named rectangle. And you could see in the debugger that when you passed it by value, the parameter, it didn't have a name member variable. Right? And when you did it by reference, it did. And it called the overloaded, I think it was like display, which built a display string that said height, width, name. No stars, no points tos, just explaining polymorphism as polymorphism. None of the magic of pointer explaining, no address of, no nothing. Just focusing on the thing you're trying to teach them, which is polymorphism. And they get it. They get it the first time because it's not obscured by how difficult pointers are for most people. Having passed anything by reference, it is a perfectly normal and natural segue. In fact, sometimes someone in the class will give this to you about const. Because they'll say, in your other example, when we passed the integer by reference and we changed it, the real integer changed. So now when we're passing the rectangle by reference so that we can get the virtual function, couldn't somebody change the real rectangle? And you could be like, yes, they totally could. And you might not want that. and here's an amazing keyword, right? And then you can do, again, that Cook's tour of if you put the const here and the const there. And James has got a const on the left, const on the right rant. You can play that game, but you can also like the difference between a const pointer versus pointer to const. You can play all that game if you want, but you started with a good reason for why you'd want to mark something as const. So you've naturally put them in that place to talk about const. We talked about const in a one-day intro to C++ course. Okay? We got that far. Because not only did we skip ugly, difficult, hard stuff, the stuff that's normally hard, people got in a much shorter time than usual. Right? Normally, polymorphism is a really tough thing. You have to draw all over the board. For some reason, once we switched to teaching polymorphism with references, people just get it. And you have way more time to move on to other things that you would like to cover. And I don't expect you to necessarily believe me, so I want to challenge you to try it. Because I tried it in some other contexts. And it's an absolutely stunning phenomenon. Pointers are really, really challenging. And references are just less challenging. So when you teach polymorphism with references, you can focus on teaching polymorphism rather than being all bound up in teaching pointers. And then that puts you into const. And being in const, you should have probably spoken about intent already. I speak about intent from day one. The difference between a hand-rolled loop versus calling find versus calling count versus whatever. You're expressing your intent. And that your code is as much to be read by humans as it is to be read by the compiler. So of course the compiler reads const, but human also reads const. So to express to other people what is going on in your code and to give them that foundation from their first week of learning C++, that this is a good and normal behavior, that you are writing code to explain what you want, to explain what you mean, and to help the person who has to edit this code 20 years from now to know what you were thinking when you wrote it. You're now in a good place to talk about scope. You've done objects and classes, you've done polymorphism, you've done some const, we've passed things to functions by value and had those temporaries go away. We've passed things to functions by reference and had there not be a temporary. So we're talking scope at this point. We might as well stop, take a big breath, and put up a slide on the screen that says scope. And of course, that naturally brings us into RAII. Now we haven't been near the heap yet. So we are presenting the normal and sort of default lifetime as being a stack semantics lifetime. And in today's C++, that is the normal. If you think about advice to use smart pointers, the smart pointer itself is on the stack. Sure, it goes and news something up, whatever. So does vector, so does string. I don't care. That's a hard thing for us to accept if it was our job to care for a really long time, right? And if you're a libraries writer, of course you care. But if you're somebody who's being hired to write or maintain modern C++ code, your default thinking should be a stack thinking. So they don't even know there's a heap yet. We haven't told them there's a heap. We're going to talk about scope, we're going to talk about lifetime, we're going to talk about RAII, and we're going to talk about non-memory resource management. Because in a garbage collected language, you don't worry about memory. And the rap on C++ is that you have to worry about memory. And if you want them to dislike C++ and think it's hard, then go ahead and focus on memory the minute you start talking about lifetime. But if you want them to see where C++ can be good, focus on the deterministic destruction of non-memory resources, on closing the file, on releasing the lock, on closing the database connection, and having those things be done for you when objects leave scope, not having to remember to call close. If you are feeling mocky and you know your audience, you can point out the languages that have added constructs to try to get them some form of deterministic destruction for non-memory resources like using, right? And so in C# you have a using block that calls dispose at the end because they missed having that natural and automatic lifetime management. The classic demo here is a class with a whole pile of constructors that say copy constructor went off, default constructor went off, and so on, and a destructor And then you run a bunch of things and people can see things being created and destructed, right? Just be careful. You don't want to be 6 demos in and then have some like return value deleted. And so the things that, I thought there would be a pair there. Oh, right, RVO, okay. So make sure you know what you're showing and what you're not showing. But squawking in destructors is a pretty good way to show people what's going on. Or, of course, the debugger is still your friend. With scope, with destructors, it's okay now to talk in Intro to C++ about exceptions. The idea that we leave scope for a different reason than returning, for a different reason than reaching the brace bracket, but that the same things still happen. And if you want to talk about what motivates exceptions, about, I don't think most people really think running out of memory is a thing anymore, but, files not being found that someone just browsed to, then when you go to open it, it's not there, that kind of thing. And give them some examples of what exceptions might be caused by. And the disruption, if it comes right after a discussion of scope, there's almost no disruption at all. Okay, and you can just present it as a benefit of not having to check a chain of return values, for example. Does that mean you should never teach pointers? No, it does not mean you should never teach pointers. You don't need to teach pointers for the usual reasons that we get stuck teaching pointers on day 1 and day 2. You don't need to teach them so that you can iterate through square bracket arrays. You don't need to teach them as pointers because you're passing by address, because we're going to use passing by reference for that capability. And you don't need to teach pointers so that you can teach polymorphism. Because the later you teach pointers, the better. When people are working, deliberately or not, with pointers on day 1, they are doing that voodoo stuff. They are just typing stars and ampersands in the hope that their code will compile. When you teach pointers on day 4 or 5, they kind of feel like they're beginning to own this language. They're beginning to understand what a lot of the punctuation means. They've passed some things by reference and by value, and they're understanding what it means to put that punctuation at the end of the type. And they're kind of ready for this idea of decorating types. And they are more comfortable and more confident and less likely to say, I don't know what I'm doing, the compiler knows everything, I'm just going to randomly try stuff. And they're more likely to feel like, I get this language, I have a little bit of mastery, and I'm going to listen when it's explained to me. And so they can actually work properly with pointers at that point. So the number 1 reason to use pointers is, of course, because you're putting something on the heap. And the number 2 reason is because you either want to have null pointer available or you want to be able to repoint it. Right? Because you can't re-refer a reference, but you can repoint a pointer. Fine. So, you say, here's your basics, but when you write a real program, sometimes a person opens a bank account, and that bank account object needs to sit around, for quite a long time. That brings you to the heap. So I spend a very short amount of time on new and delete, and then basically tell them that they're soaking in it because you use objects that do the newing and deleting for you. And remember, they have now been hand in hand with vector and string since day 1. So you can tell them that, in fact, when they make a vector of whatevers, the whatevers are on the heap. When they make a string, and don't talk about short string optimization, when they make a string, the characters are on the heap. It's just not their problem because they trusted the object to do it for them. And then that puts smart shared pointer and unique pointer in exactly that category. Yes?
But do you really need to teach new now that we have make unique and make shared?
So I don't think it's fair to call someone a C++ programmer who's never seen the word new. But when I say 5 minutes, I mean 5 minutes. Right? Like I show it to them and then say, but we don't do that. That's for library writers. And move on. If you're scared of templated classes, including vector, and you don't teach them until 5 days after new, then you can't count on their comfort and familiarity and trust of vector to make them feel okay with smart pointers doing their allocation and freeing for them. But if vector is an old friend and string is an old friend, then the smart pointers, they're just cousins, right, to these useful working classes. There we go. The really hard part is coming up with a good use case for shared pointer. We are lazy. We like using shared pointer because then we don't have to move. right? You just copy the thing around all over the place and everything will be fine. If we make a unique pointer, we got to remember when to call move, and go to a whole 1 hour talk about when to move and when not to move. So we just use shared pointer, which is really wasteful. And I've said don't care much about perf, but if you were to teach a bunch of beginners to always use shared pointer because it's easier, you really would be doing the world a disservice. So present unique pointer as kind of your go-to pointer and come up with a use case for shared pointer. And it's a little bit of a challenge, actually, to come up with a good use case for shared pointer. Go ahead.
My favorite use case for shared pointer is the ability to keep weak pointers to shared pointers that are stored in a cache that may be invalidated.
The fact that shared pointers have weak pointers is actually, yes, that's a very good, because it doesn't keep them alive. You just want to be able to cache the pointer. The example I gave, and it may be a little bit out of date already, but the last time I did this, I was using a Twitter client that had multiple columns. And I said, imagine that there's like a picture in a tweet, and that tweet's in multiple columns. One's everyone I follow, one is like the CppCon hashtag, and one is mentions of me. And you don't obviously want 3 copies of the picture, so you want each one of those columns to have a pointer to it, and you don't know at what rate the columns are going to be scrolling off the screen, right? So whoever scrolls off last, that's when we can throw the picture away. And that you need to come up with a case like that makes shared pointer seem like the exception, not the norm. Because it should be the exception, not the norm. So don't just teach them that this is easy, just use shared pointers, you can pass them around, and the last one out turns off the lights. You're not making good C++ programmers if you do that. So have them always use smart pointers, but have them use the right smart pointer. Oops. Null pointer. You do need to talk about null pointer. It is still a signal value, right? And in order to pass pointers, raw address of pointers, not things you got back from new, you got to teach them the address of operator. And at this point, and you have to practice this sentence so you'll giggle, right? You can say, pointers are kind of like references. And the kinds of things I've shown you that you can do with references in polymorphism, you can also do with pointers in polymorphism. And it is really tough to do that with a straight face the first couple times, but they get it, okay? And now you can repoint the pointer. And there's nothing wrong with raw pointers if they're not owning raw pointers, right? So if you've got some hierarchy where every customer has a whole bunch of accounts, those should be some kind of smart pointer to an account so that when the customer, say, stops doing business with the bank, all their accounts will go away. But it's okay for the accounts to have a raw pointer back to their customer that they can use to, God, you can't even do good examples anymore because there's no such thing as a printed statement. But remember printed statements? So you need to ask the customer for their address to print it at the top of their statement. Feel free to bring that up to the 21st century. But there's, raw pointers aren't bad. We kind of overswung for a bit. We were never going to have a raw pointer again in our lives. A raw pointer from new is bad. A raw pointer from address of that's only used for finding your parent or container or owner or whatnot so that you can ask it to do something is not bad at all. And in a case where, for example, an employee can move from department to department, you obviously need to be able to change their department pointer to now point to their new department, right? So having sensible examples that you can present worked out that show the motivation for why a pointer is a better plan here, a raw pointer, absolutely nothing wrong with that. So if you toss the C stuff on day one, and if you teach polymorphism with references and wait as long as you possibly can to do pointers, you will be able to cover all of this. Objects and classes, inheritance, polymorphism. They'll certainly see operator overloading. You may have time to teach them an operator overload. They'll know about scope and destructors and RAI. They will be comfortable using templated classes and functions. And the standard library will hold no fear. You'll have taught them const and exceptions and lambdas in a beginner course. Because you will not have covered the delights of printf format strings. It's a great place to show off how smart you are, and it's a great way to use up a ton of time, but not doing it doesn't really hurt much. You will not have covered what I like to call str star, right? And I don't just mean strlen, strcpy, strcmp, blah, blah, blah. When do you need strn whatever? When do you need the ones with the underscore s on the end? What's the special pragma so you don't need the ones with the underscore s on the end? Let's have a half-hour discussion about buffer overflows while we're at it. on day one because we wanted to stir copy the person's name into the name variable, right? Skip all that. All the stuff about not allocating enough, allocating too much, looping too far, not looping far enough, less than versus less than or equal to. Oh, you need to stick a +1 on the end of that. Oh, you need to stick a -1 on the end of that, which is another set of voodoo-ness, right? I'm getting a runtime error. Let's put -1 here and see what happens. You get to skip all that. And not only is that freeing up time for you to talk about important things like RAI, it's taking away the bit where they go, I took C++ 20 years ago and it was awful. That awful doesn't come from it being C++. I mean, okay, yeah, if I showed them variadic templates, or Svine or something, then they could fairly say that, it was scary and awful and difficult and hard and you have to be super smart. But the fact that they're saying it's scary and awful and hard and you have to be super smart because sometimes you have to add 1 is like really unfair of us to have set that up. And we don't even need to because there's nothing to be gained by doing that. And of course, the magic. I don't say cargo cult anymore. This doesn't fit in this talk, but we can talk about cargo cults, which I learned a lot about this summer. And people who say cargo cult are actually doing what they think the cargo cult people are doing. But I will say robotyping, where you're just randomly stuffing punctuation in the hope that the compiler will grant you a build succeeded. The longer we put off talking about pointers, the less of that we have. And that's a win for absolutely everybody. And of course, yes, question?
How do you remove constructors and all this stuff when you go to unique pointers?
I say that you cannot copy a unique pointer. You can only move it. Here's how you move it. Yeah, eventually we're going to have to talk move constructors. We might even have to talk R-value references, but I'm not trying to make library writers. I'm trying to make library users. Okay? It's all right if you're going to be inducted into the tribe of library writers for someone to pull back a curtain and show you a lot of stuff, a lot of punctuation, ... says Andre is where the fun begins. That's okay for the people who are going into that tribe, right? But for the library users, you would be amazed the power of a teacher confidently saying that something is simple. You can't copy unique pointers. You have to move them. Here's how you move them. Moving on. And then they're like, okay. The same as when you just say, well, A here is a vector, and this is a vector, so if I say A equals B, what do you think happens? Yep, that's what happens. Moving on. It only seems a miracle if you remember the old way. Yes?
Do you ever talk about regular types?
You mean like what makes an int different from a string?
No, like a type being regular, so it can be default constructed. When you assign it, it is a copy.
It gets
and a
bit-blitted.
true one, and
Yes.
so on.
Usually not in an intro course because again, when does that matter?
When
Right?
you're not a user.
Maybe when you're writing a template. And I don't want to suggest that everyone who writes a template is a wizard and is in a different category. But they don't need to understand everything all the way to the metal in order to write successful code.
I mean, no, that doesn't matter when you write templates. That matters when you write user-defined types. At any point when you write user-defined types, you should be trying to make them regular so that they behave like actual regular things.
Right. So let's say I write a class called employee, and I don't write any constructors. I can make a vector of employees. Right? Then I decide I'm going to add a constructor that takes, I don't know, a name and a birth date, and suddenly I can't make a vector of 10 employees anymore, right? Because I don't have a default constructor. So then I have to explain what the compiler does for you and all of that. But that's a different philosophy, which is different from the stop teaching C philosophy, which is that I try to let a problem naturally occur and then show what to do about it. And so that's when that would come into play. And if you want to give it a name and say, this collection of statements about a class has this name, that's also a good place to do it.
Yeah, because what I found was that my students often don't think about the fact that, this class is holding some kind of pointer to a resource, that they're not copying when the whole class is being copied, and they're introducing a whole new class of bugs by not thinking about transitive
copying
relationships. Basically.
Right, so that's about, again, if you're using a raw pointer for ownership, and then you have to write the code to do the deep copy. So this is the rule of 3, 7, 11, 52, 0, right? And I like the 0 version of the rule the best. And so that's part of it, right? That if you follow this certain set of ways of behaving, then you live in a rule of zero, then you don't have to have the talk about, don't forget, if you write an operator equals, you got to write a copy, like all of that. You know, I'm not saying that nobody needs to know that. But I am saying that if we live our lives in a way that we have to teach them that on day 2 of Intro to C++, we are making the language harder than it truly is. That's kind of my point. I'm not saying don't do these things. I'm saying don't set your course up so that you have to teach these things in order for people to finish the course. Fair? Right? Misery, confusion, swearing. Skipping that stuff makes people like your course. People tell me stuff like, I thought C++ was supposed to be hard. I hear that a lot. I love getting those emails. They told me I had to learn C++ at work because of this new project we're doing, and everyone else stepped backwards and I was standing forwards, and so now I have to go on the C++ course, and I took your course, and joke's on them. Turns out it's not that hard. My favorite, why does my boss think? I cannot tell you why your boss thinks that C++ is all about pointers, that C++ is all about new and delete, that C++ is all about bitwise manipulations and bit twiddlings. I'm not responsible for whatever childhood your boss had. Now, it is fair, in certain work environments, people who go through this experience will be deficient in some things, right? They will not be able to read that C compiled with a C++ compiler stuff. You know, I worked on modernizing a bunch of code where the guy was moving the null around inside strings so that he could use stir whatever. So he'd have like a 100-character string, but he'd squirt a null in where there was a space so that he could use strcpy, and then he'd put the space back. And of course, all this done with some giant loop that was going P++ and P minus and stuff all over the place. And those people who spend the day or the week or whatever learning modern C++ without learning C first, when they hit that code, they will be deer in the headlights. Okay? So if you're teaching people in-house and you know there's some of that code, schedule a day called How to Read the Old Crap. That's fine. There are some idioms. If P is equal to some function that returns a pointer, not equals equals, right? A sign, right? So that if the function returns null, we don't go in and do things with P. If that's an idiom that's throughout the code base that you believe these people are going to go, when you do pointers, when you talk about null pointers, show them that idiom. Okay? Don't show it to them on day 1 when they don't even know what a pointer is or the difference between the two kinds of equal signs. And if you are going to teach people that idiom, you need to live on a warning level that warns when you do that wrong, when you stick it in integers and stuff, right? I also no longer do how many bytes are in an int, a char, a blah, blah. Try to explain that when you type quote, a quote, you don't get a char, all of that. I just don't even do that. It puts way too much strength and importance on fundamental types. And sets up a dichotomy between fundamental types and user-defined types that's less true in C++ than it is in any other language. So I literally don't even worry about the fact that on day 1, some of them think string is built in like int. Like I don't care. In fact, I think it's kind of a feature that they think string is built in like int. Like that means string was written well, right? That's our goal. That's what we want our classes to be when they grow up. And so tables of these are the fundamental types which you can memorize and everything else is not, is working against that spirit. And the same with operator precedence tables. Just have lots of brackets or don't use so many damn operators. You're teaching them. Overall, it is my position that you will have a win-win, that they will enjoy the training more and be better. We can be a little bit masochistic as a tribe. If it's fun, you're probably not learning. If it was easy, then you probably didn't end up smarter. And I want to say that that's not true, that it can be fun and easy and make better C++ programmers. Because they think objectly. They think RAII. They're using the standard library. They're using lambdas. They understand the punctuation that they're typing. These are all good things. They are happier, but they are also better. And that is why my plea to you is to stop teaching C. And I have 6 minutes for questions. Yes?
Do you think that C++ can be used as a first language, and also at what age could you start teaching kids?
Kids, so...
this? And then also, how would that compare with other languages that don't have to deal with a lot of these issues, maybe Python, for example?
I did not used to think that C++ could be a first language. So when I taught my own children to program, I didn't teach them C++ first. However, I was asked a year or two ago to write a C++ as a first language course, and I was goaded into doing it, so I did it, and it can be done. And you can take someone who literally, you have to say, sometimes you want the computer to do the same thing over and over again. We call this a loop. You can do that and show them a C++ loop. You can do it. Because you don't start with how many bytes are in an int and whether a long is really longer than and all of that. You just don't do it. For kids, the big benefit of other languages is not about the language, it's about the library. It's about that they can write Hangman on day one, right? If you find a library, whether it's Cinder or whatever, that you can play that with, and they can be writing Hangman or exploding the asteroids or whatever on day one, then there's no reason why you can't. The semicolons are not bad. Okay? In fact, I mean, when I first met Python, I'm like, was this person scared by a brace bracket as a small child? I don't understand. There's nothing intensely difficult about brace brackets or semicolons as ways of showing that you're done compared to a textual spacing like we had in Fortran, which I thought we had left behind. So yeah, you could teach it to kids. You can certainly teach it to beginners. In some ways, having experience with C is now a detriment to being a good C++ programmer compared to having experience with a more objecty or a more function language.
What age group are we talking about for teaching?
I don't know ordinary children. I just know my children, and we're seriously talking like 10, 12. When they still think you know stuff, that's a good time. Back here.
So at which point would you start teaching unit testing? Another question, build systems.
So build testings, unit testing, build systems, source control, work item tracking, process. It's all super important, but to me, that's orthogonal to language. Depending on the platform you're on, you're going to go a different way for testing. You should be testing. If you're teaching your own people, then write unit tests on day one when you're writing the hello world thing and say, and I will test it that, the sample I like to write, it asks you your name. And if you say Kate, it says, hey, I know you. And if you say anything else, it says hello, whatever you said, right? And so you could write a test for that. And you could do that right from day one. There's no reason not to. I think that any time you wait and bolt something on at the end, you send a message that it's not really important. But I think it's orthogonal to language choice.
Do you ever go into, pure functions, passing thing is either by value or const ref, returning multiple values in the tuple and so on?
Again, when somebody has a need for it. It's true, you can only return one value. Most people just accept that, right? Then somebody comes along and says, but that one value doesn't have to just be an integer, it can be a thing. And then offering them pair and then tuple is a natural way to tell them they don't have to write classes if all they really want to do is tie some things together. But that happens less often than you'd think in wild code when you're not writing a library. So a lot of times I'll write a tuple to hold 3 strings, and then after a while I'll be like, you know what, I really should call this employee, right? So in production type code, because there's not a lot of information in tuple compared to writing a class, so it doesn't often stick with you. Yes?
So which standard version would you teach today? Was it 14.11?
Whatever the compiler, usually people have to learn in an environment. Okay, so if it's an in-house course, that's what compiler does this company use? If it's a university, I have to first persuade them to come up to a compiler from this century, and then so I'll take the absolute latest that I can get. But even then, it's like, well, what machines are they running these on? Do you guys have like a MSDN academic, or am I not going to do any Windows work? Like, those are your choices, right? So it doesn't really matter as long as we at least have 11. I'd like to have 14 so I can have make unique. Okay, I'll grant you that. But if I can't have make unique, then I can just wave my arms and say, as soon as you get out of this room and you can get a real compiler, you will have make unique. And I will show them make unique on a slide.
Could that not be introduced as a trust me above the code?
Trust me on this magic. Yes, or maybe I'll write one that's not in the stud namespace, right?
Yeah.
Because it's not exactly a long function. Yeah. For me, the key is that they understand that it is a language that changes and that grows, and that they can't just put a tick next to learn C++. So I don't want too much diversion about, now this was not, if you're not on the latest version, blah, blah, but a little bit of it is good so they understand they are living in a dynamic environment.
I'm going to selfishly grab the last question with less than a minute left. When is your college level textbook being published?
Here's the deal with books. A girl
It's
can
not about money.
a girl can only make $30 a month for so long.
It's
you
not
know?
about money. It's about
Yeah.
making the world better.
Yeah, so I am trying to make the world better, but I'm trying to do it through leverage and indirection. So go forth and make the world better, please.